Hello, everyone. Welcome to Unit 3, Day 21. Today, we're just going to do a little bit of mixed review based on what we saw in the quiz today, or actually in the quiz the other day, where we kind of struggled with sampling distributions and confidence intervals. The hypothesis testing part of the quiz went great, but it seems like either we didn't go back and study these things or we are confused on these things still. So I'm going to go over the exact same questions that were on the quiz, just kind of as a way to do a little bit of review and reintroduce these two topics, the sampling distribution and the confidence interval. All right. So let's talk about sampling distributions first. And essentially, what we're doing here is we're finding a probability. All right. So when we read this problem, at some point, they're going to ask us to find a probability. And sometimes we will use the normal distribution for the population, and sometimes we'll use the normal distribution for a sampling distribution from the population. And we have to make sure that we can distinguish between the two. All right, so let's read this and I'll start pointing out those little nuances. All right, so here it says, according to an article, Our Baby's Normal by Tracy Clemens and Marcela Pagano, published in the American Statistician, blah, blah, blah. Right, the birth weights of babies are normally distributed with a mean of 3,333 grams and a standard deviation of 561 grams. All right, so they are telling you about your distribution for the population of babies. All right, so for all babies, right, the mean weight of all babies is 3,333 grams. And then this standard deviation thing kind of tells us how spread out the data is. Right, so whenever I'm told about a population or a distribution, I always think about the shape, the center, and the spread. All right, first thing they tell us is that it's normally distributed. This tells me the shape. Right, so that means we're going to have something that looks like this. Right, so we have a normal distribution. We get that bell curve, and the center. Right, the center is going to be the mean. Right, the mean is a measure of center. They're telling us the center of this distribution is right here, and it is 3,333 grams. All right. Now, the standard deviation, what it tells us a little bit more. It technically tells us about the spread, but it also tells us a little bit about the shape, right? So when I think about the standard deviation and its effect on the normal curve, it tells me whether or not my normal curve is going to be like a wide normal curve or a skinny normal curve, right? So if the standard deviation is really low, we're going to see a lot of our data concentrated around the middle rather than spread out along the curve. All right, so we'll demonstrate that when we get to the sampling distribution. But let's read what they want to know, right? They want to know what is the probability that a randomly selected baby, right? So notice the wording here, a randomly selected baby. That is singular, that is one baby. If we were to randomly select one baby, we want to know the probability that it weighs between 3,200 grams and 3,500 grams. So let me switch pen colors here. So 3,200 grams, let's say is somewhere over here, and I'm just eyeballing this, right? So we're going to say 3,200 is here, and 3,500 is somewhere over here to the right. Okay, and if we want to know the probability that one single baby is between these two weights, then we would find the area underneath the curve in between those two weights, right? So we're essentially trying to find this area, underneath the curve. All right, and we can do this using what's called a normal CDF function. The normal CDF function calculates that area as long as you tell it the two boundaries and you tell it about the distribution. Okay, so when we go to our calculator, we're going to do normal CDF, and I'll show you how to get there in just a minute. And the first thing that it's going to want to know is what is the mean of your distribution. So you'll tell it the mean is 33, and then it's going to want to know the standard deviation of your distribution. So you're going to tell it 561, and then it's going to want to know the left bound. So we're going to tell it, well, we're going from 3,200 to 3,500. Okay. And when we put this into our calculator, it'll spit out a number at us, and that number will be the probability that one randomly selected baby is between these two weights. All right, so let's give it a try. Okay, so on your calculator, go to on button first, right? And you see distribution here in blue, so I'm going to hit second vars. And you'll notice normal CDF is option number 2. Now, I know Mr. Van Slyfer showed you how to do this on Desmos as well, and you're more than welcome to use the Desmos calculator to do this. I like my normal CDF on the TI-84. All right, so it wants to know what's your lower bounds. Remember, we wrote all this out here, so 3,200 is our lower bound for this problem. All right, and then our upper bound was 3,500. And then it wants to know the mean. No problem, that's 33, 33. And then the standard deviation was 561. And then it'll say pace. And it'll, when you put it on the screen here, it'll look very much like what we wrote out here. Okay, so you hit enter, and there's our probability. So we're going to say 0.2107 because it wants 4 decimal places, so 0.2107. So we would say, in proper notation, we would say the probability that a baby, right, which we'll say is X, is in between 3,200 and 3,500 grams is about 21%. Okay, so pretty easy, right? But you got to pay attention to the wording. If it's a randomly selected baby, just one singular baby, we're going to be using the population distribution, all right? However, if we change the wording of the problem, right? So if we read this one, what is the probability that the average weight of 28 randomly selected babies is in between the same 2 bounds? All right, so it's no longer a singular baby. Now it's 28 babies. I'm going to take 28 babies. I'm going to weigh them. I'm going to find the average weight of those 28 babies, and I want to know what's the probability that the average of those 28 babies is in between 32 and 3,500. All right, so that means that we are pulling from a thing called a sampling distribution. And a sampling distribution is a little bit different, right? So a sampling distribution is created by taking 28 babies over and over and over again, right? I'm going to take 28, I'm going to find the average. I'm going to take another 28, I'm going to find the average. Take another 28, find the average, so forth and so on. And I'm going to do this a very, very large number of times. And as I do that, I'm grabbing a data point every single time, and that data point makes up a new distribution. That's what's called the sampling distribution, okay? Now, as the sample size increases, right, so going from 1 up to 28, what that does to the shape, it's still normal, but it's a skinny normal, right? So we're going to have a very skinny normal curve, okay? That means our data points are going to be more concentrated around the center. Now, going from the population to the sampling distribution, the center stays the same. So the center is still going to be 33, 33, right? The shape changed a little bit, right? Because it became more of a skinny normal curve, and which means the standard deviation also has to change, okay? So the way we say this, we use a different notation. So we say the standard deviation of the sample means, okay? This is to differentiate between the standard deviation of 561, right? This is the standard deviation for the population. This is the standard deviation for the sampling distribution, and they are 2 different things, but we can calculate what the new standard deviation is going to be. We can take our old standard deviation, 561, and calculate the new standard deviation by dividing that by the square root of the sample size, okay? So if I do this calculation, right, we get 561 divided by the square root of 28. And there it is. So we get a new standard deviation of 106. And we'll take that to 4 decimal places, so 0.19. All right, and you notice that it got a lot smaller, which is what we expected because we have a skinnier normal curve, so there should be a smaller standard deviation, and that means that the data is not as spread out as it was before, going from the population to the sampling distribution. All right, now we can run our normal CDF, so we can say normal CDF, right, and it wants to know the mean, right, and the mean of the sampling distribution here is the same as the mean of the population, so 33, 33. The standard deviation of the sampling distribution we just said was 106.019, and then our lower bound, right, was 3,200. Our upper bound, 3,500. Okay, so let's run this. We're going to do another normal CDF. I'll put this over here. There we go. Lower and upper bounds stay the same. Pretty much everything stays the same until we get to the standard deviation, and we're going to put in that 106.019. The other thing you can do is you can just type in this directly, so you can take the 561 divided by the square root of 28. Right, that way there's no issues with intermediary rounding. Okay, so you can actually type in the exact expression. You don't have to worry about any rounding issues there. So if I hit enter and paste, it'll do that automatically, and we get our new probability, which is 83.75%, right? But I'm going to write it as 0.8375, right? So 0.8375. Let me make sure I rounded that correctly on the fourth decimal place. Nope, that should be 876. There we go. And there is our probability. And all right, so you'll notice that the probability got much bigger when we went to the sampling distribution compared to the population distribution. Remember, our bounds and our center didn't change, right? But our normal distribution got much skinnier. So 3,200 is actually like way out here and way over here, right? So this could be 3,200 over here and 3,500 over here. And the area underneath the curve is all of this stuff, okay? And you'll see much more of the data is contained inside of that boundary than it was with the population distribution. So we're getting more of the area underneath the curve because more of the data is being pushed towards the middle. All right, that's why that probability jumped up so much, which is why researchers really like using the sampling distribution much more than the general population distribution because it is much more reliable. All right, so something to think about there. If you guys have any questions on sampling distribution, please make sure you ask. Let's go ahead and jump over to confidence intervals. All right, confidence intervals are used to estimate something. All right, their primary purpose is to take something that we really don't know and estimate what we think it might be. All right, so let's read this scenario and let's see what we can do with a confidence interval. All right, so it says you recently sent out a survey to determine if the percentage of adults who use social media has changed from 54%. All right, so what this is telling me is that at some point in the past, a study was done or research was done, and it was determined that 54% of adults use social media. All right, and so they're telling me that was 5 years ago that they determined this number. All right, so the question is, has that changed? Is it still 54%? And so right now we're not sure exactly what proportion of adults actually use social media. So we're going to estimate what we think it is using a confidence interval. All right, so it says they surveyed 3,010 people. Okay, so that's an important piece of information. That is our N value. And 1,753 stated that they currently use social media. So that number there is our X value. All right, so I know I'm going to be using those two numbers at some point, and I'm going to be comparing my confidence interval to that 54%. All right, so it says use the data from the survey to construct a 93% confidence interval estimate of the proportion of adults who use social media. All right, so here's a key word, right? Because we're estimating something, but what is it exactly? Well, it's a proportion. All right, so you want to look for keywords like proportion or mean. Those are the only two things that we've taught you to estimate in this class. So you want to make sure you know, are we doing a proportion or are we doing a mean? In this problem, we're doing a proportion. All right, so we can calculate a confidence interval very easly, again, using our TI-84 calculator. So I want to show you how to do this. So we're going to go to Stat, and we're going to go over to Test. All right, so I hit the Stat button, I went over to the Test menu, and you'll notice a bunch of options here, and we are doing what's called a one prop Z interval. Okay, So you'll see like here, option 7 says Z interval and option 8 says T interval. Those are the ones that you'll use for a mean. Okay, but since we're doing a proportion, we want the one prop Z int, right? So this one right here is option A. And it's going to ask you for all that information that I circled and highlighted as we went through the problem there. Okay, so we're gonna tell it, well, our sample size was 3010. So I'll go down here, type in 3010. The number of people, right? The X value, this is the number of people who responded yes, they currently use social media. We call those successes. So they're asking you for what were the number of successes in your sample. So we had 1,753 individuals who state they use social media. And then it wants to know what confidence level do you want? And according to our problem here, we want a 93% confidence interval. So I'm going to type in 0.93. Then you just go to calculate, right? And it'll give you the confidence interval that you need here. And it tells you what form to put it in, okay? So this is what's called interval form, and it's probably the easiest one. It's the form that the calculator uses. So we're going to go to 0.5661. And the right bound of our interval is 0.59868. And it says round your final answer to 4 decimal places. New problem, so this is going to be 0.5987. Okay, so there is our confidence interval. All right, so right now, probably to you, these are just a couple of numbers, and you're like, well, I don't know what these mean, but that's the correct numbers because Mr. Weldon said so. All right, well, let's think about what this is telling us, right? So we are estimating the percentage of adults who use social media. And so if I said, hey, what percentage of adults use social media, you wouldn't spit out an exact number at me. You wouldn't say, well, it's 50%, right? You would say it's probably in between these two numbers, right? It's probably in between 50 and 60%, right? This is normal conversation between people, okay? And so you ran a confidence interval. These are the two numbers that you would say. You would say, I'm pretty sure it's in between 56% and looks like 60%, right? So I'm pretty sure it's in between 56 and 60%. Now, as statisticians, we're going to be a little bit more precise, and we're going to say, well, I'm 93% confident that the proportion of adults who use social media is between 56.61% and 59.87%, right? Because we're trying to be more precise, we're trying to be more professional about it, all right? But that's what these numbers are telling you, right? Based on our data, we're pretty confident that the actual proportion of adults who use social media is in between these two percentages, right? So the question is, has it changed? Right, so 5 years ago, they said it was 54%. But if we look at our interval here, we're pretty confident that it's in between 56 and 59%. All right, so I would say yes, right? Yes, the proportion of adults who use social media 5 years ago is not inside of the confidence interval, okay? So if that 54% was within these two bounds here, then I would say, I don't think that the proportion might have changed because that old proportion is within what we estimated. All right, so we're going to say yes, it has changed, and that is because the proportion of adults who used social media 5 years ago is not inside the confidence interval. So this is the one that we want. All right, and on MyOpenMath, they give you these options here, and they word it slightly different in each one just to try and trip you up because they really want you to think about how you are interpreting this interval. All right, so this is how we interpret it to kind of talk about whether or not that proportion has changed. And now we just kind of want to interpret our confidence interval. And these are some of the interpretations that I saw on the quiz last week. Now remember the two numbers that we came up with here, right? The 0.5661 and 0.5987. So here's one way that we could say it. We are 93% confident that the true proportion of adults who use social media is between 0.5661 and 0.5987. Get that right? Yep. Okay. Another way to say it is there is a 93% chance. So it says which ones are good ones. This one says there is a 93% chance the true proportion of adults who use social media is in between 0.5661 and 0.5987. This is not a good one. This one is not. This is not a 93% probability. Okay, confidence and probability are two different things. Never use the word chance, never use the word probability when interpreting a confidence interval. Don't do it. All right, I have to mark it wrong because it is not a probability. All right. So the first one's good, second one's bad. Let's see this third one. This was another one that I saw. We estimate with 93% confidence that between 0.5661 and 0.5987 of all adults use social media. This is a good one. I like this one, right? So we're estimating with 93% confidence that between 56 and 59% of all adults use social media. That's a good interpretation of the confidence interval. All right, so this first one, make sure I highlight this, right? So this one and this one are good interpretations, and you can use either one of those kind of like a template to help you write your interpretations in the future. All right. A side note, feel free to use the calculator on these confidence intervals. From here on out, you can use the calculator. You do not have to build these confidence intervals manually. I know Mr. Van Slyfer took a lot of time to explain how to do it manually because we want you to understand where all of these numbers come from, which is a good thing. But in reality, when we're doing this in practice, no one is calculating those from scratch. So using technology is a pretty I should say a pretty normal thing for statisticians, okay? So when you see these confidence intervals, you're going to be running one of the three, one prop Z and Z interval or T interval. It's going to be one of those three. You just need to figure out which one it is. All right. Okay, guys, that's the end of the video. If you have any questions, let me know in the Zoom chat. Have a great day.